When you are wanting to find out information about a whole huge group of people, let's say the population of the United States, or everybody at Prairie Point, or everybody in Cedar Rapids, often you can't ask everybody the question that you want to have answered. So what you do is you take a random sampling of the population being the entire group that you want to know something about. So everybody in the state of Iowa or everybody in the United States. You take a random sampling, which means that everyone has an equal chance of being selected. You survey those people, or you count the things about those flowers or whatever that sample is, and then you use that information to say, well, if this fraction of my sample thought this way or looked this way or whatever I'm measuring, then I can assume that that fraction would also work for the entire population as a whole. So what this means is that if we have 127,905 people in Cedar Rapids, they did a random sample, let's say, to find out if people were going to vote in the upcoming election. So 1,500 people said that they would vote. Well, they surveyed 1,500 people. 1,175 said they would vote. So the sample proportion of people who would vote is 1,175. That's the number that would vote over the number actually surveyed, over 1,500. Now you start there, but then you reduce that fraction, and it reduces to 47 over 60. The sample proportion who might vote, well, it said 300 people responded that they might vote. So 300 might vote out of the, again, 1,500 who were surveyed, and that is going to reduce to 1 over 5. You need to show the original fraction, and then you need to show me how you reduce it if possible. And the sample portion of people who would not vote, well, 25 people say they will not vote, so 25 people out of the 1,500 surveyed, and again, reduce that fraction and it reduces to 1 over 60. So from my sample population, these are my fractional amounts for people who said either they would vote, might vote, or would not vote. Now, we have to make an assumption at this point that the larger population, 127,905 people in Cedar Rapids, would respond with the same responses, with the same fraction, to be able to answer the following questions. So the number of people out of the total population expected to vote, maybe vote, and not vote. So expected to vote, and I'm sorry, that's a little bit sloppy. Okay, it's more than a little bit sloppy. Expected to vote. Well, 47/60 of the people are expected to vote. Multiply that by the entire population of 127,000. I'm going to put this in parentheses, 127,905. And that means, in this case, it doesn't make sense to round to one decimal place, even though the original data is in whole numbers, in integers, because you can't have a decimal of a person. So we're going to round to the nearest person, which makes more sense. So we expect 100,192 people to actually vote, for sure. Now, may vote, so these guys may vote, they may not vote. We ended up with 1/5 as the fraction who may vote, again, times now the total population of 127,905, and I end up with 25,581 people, again, labeling my answer, people who may vote. And then will not vote, my fraction of people from my survey who would not vote was 1 out of 60. Again, multiply that by the entire population of 127,905, and I end up with 2,132 people who definitely will not vote if people answered honestly, if this fraction from the survey actually does reflect a fraction from the entire population. Now, before you come to class tomorrow, figure out the information about the problem at the bottom of the page about Ely. Thank you.